Hi everyone, I hope you all are fine. Today we will discuss about the primary concept of the scalar quantities and vector quantities. You are able to understand scalar quantity and vector quantity, and know that the following quantities scalars: distance, speed, time, mass, energy, and temperature. And know that the following quantities are vector: displacement, force, weight, and velocity, acceleration, momentum, electric field strength, and gravitational field strength. A scalar quantity has only magnitude but does not have direction. We see in the two objects here, distance between two objects is 100 meter. Its only magnitude. For this reason, distance is a scalar quantity. A vector quantity. A vector is a quantity that has both on magnitude and direction. It is represented by an arrow, whereby the length of the arrow is the magnitude, and the arrow itself is the indicate the direction. Indicates the direction. So the arrow is the length of arrow, and is indicate with the symbol for a vector is the letter with an arrow over it. A is a vector quantity. It indicates the arrow. Oh. Example: the velocity of a particle can be stated as the speed of particle is 2 meter per second and is moving at the angle of 30 degree above the horizontal line. So the velocity of particle is stated. The velocity is a vector quantity. There is a scalar and vector quantities example. A lot of example here. Now we discuss about the example of scalar and vector quantities and find out which quantities is a scalar and which quantity is a vector. Now, distance. Distance, space between 2 points is called a distance. So, distance is a scalar quantity. Volume. The space of any object is called a volume. It's only for magnitude and there is no direction for this. Volume is a scalar quantity. Speed. Speed, the rate of change of distance with respect to time is called speed. So distance and time is a scalar quantity. For this reason, speed is a scalar quantity. It has no direction. There is another quantity, is displacement. Total distance moved by an object along a particular direction is called a displacement. So displacement has a magnitude and direction. For this reason, displacement is a vector quantity. And there is another example, is acceleration. Acceleration, the rate of change of distance or velocity, and the rate of change of velocity is called acceleration. There is a velocity is a vector quantity. For this reason, acceleration is a vector quantity. Mass, it's only indicate the amount of particles. For this, mass is a scalar quantity. Work. Work, we can find out the amount of work is as a energy. So energy and work both is a scalar quantity. It's only for magnitude. There is no direction. Power is a scalar quantity because it indicates the amount of work per time. It's called a power. Power is a scalar quantity because work is a scalar quantity. So power is a scalar quantity. Resistance is only for indicate the amount of amounts. For this reason, resistance is a scalar quantity. There is another example, is force. Force is the vector quantity because is the when we apply a force is the any particular direction has particular direction of this force is called a uh, for this reason force is a vector quantity. velocity. At the rate of change of displacement is called a velocity. Displacement is a vector, so velocity is a vector quantity. With the attraction of Earth is down, is always indicate the down. For this reason, weight is one kind of force. For this reason, is a vector quantity. Pressure is amount of force per unit area. So for this reason, it indicate the amount of amount. So for this only for magnitude is a scalar quantity. Momentum is momentum is multiplied by mass and velocity. So velocity is a vector quantity. So momentum is a vector quantity. There is another electric field strength. Electric field strength, the force per unit charge. The electric field strength at a point is defined as the force per unit charge acting on a small positive test charge placed at this point. So electric field is a amount of force which is acting on a positive charge, positive test charge. So for this reason, electric field strength is a vector quantity. There is another gravitational field strength. Gravitational field strength is the force per unit force per unit area. This is the gravitational field strength. The gravitational field strength at a point is the gravitational force per unit mass. So it's the indicate the gravitational force per unit mass. It's indicate the direction. For this reason, gravitational field strength is a vector quantity. Two ways to specify a vector. There's A is a vector, the origin is here, x-axis and y-axis, two-dimensional way. A is a vector quantity, the angle of this vector is theta and magnitude is A. Other process is given by the x and y components of the x-axis and y-axis. The component of this A vector x along x-axis is a ax and y-axis along a y-axis. A component of y is a y. So there is two components. X along to x is ax and along to y is a y. There is two components of this a vector. There is two methods of express the components of a vector. Already you know that the component of this vector is, we can find out that when a vector is indicated by arrow. The a vector there is two components. One is horizontal along horizontal, other is a vertical along to vertical. There is a horizontal line along the horizontal line. The component of x is ax equal to a cos theta. Let this is the right angle triangle. There is a hypotenuse, there is a base, there is a height or perpendicular. So when we cos theta equal to the base by hypotenuse, there's kind of find out the ax equal to a cos theta. Another is a sin theta equal to perpendicular by hypotenuse. So we can find out the component of y equal to a sin theta. There is such that we find out the two components of this vector ax and ay. We can use the Pythagorean theorem, or hypotenuse square equal to base square plus perpendicular square. There is a hypotenuse equal to, there's you can root over ax square plus ay square. There is such a way we find out the magnitude of this a vector. The length of a vector clearly does not depend on its direction. Thank you for watching and subscribe our YouTube channel, College of Science Q2.